of the past history. This is a little bit old data, but anyway, the operation is one of the cause of the major sudden release. But the major sudden release cause is much more with the service and bad installation. So these are the cause of the major sudden release and accident. So we have to take care of the service, that is sure. Then we have to understand what is the A2L and flammability. Historically, ammonia has been exempted from the flammable gas requirements in many standards or regulations. Japanese regulation says it is flammable, but it is exempted from anti-explosion system. Also, European or American requirements exempt the ammonia from these anti-explosion requirements. Then the class 2L was originally proposed to mimic or emulate this flammability of the ammonia to other substances. And what is the most appropriate index that was discussed, and finally we reached the conclusion that the burning velocity is the most appropriate. So these substances are very low burning velocity compared to hydrocarbon or the 152A. But these are the velocity against not moving gas, and the actual velocity is several fold higher than this. So you must be careful. Anyway, I showed the video last time, I think, but anyway, the hydrocarbon or the 152A can propagate the flame horizontally, but ammonia is due to on the ceiling side, so it can slowly spread the flame on the ceiling side, but the R32 is very difficult to spread the flame in horizontal side. Also, the 1234YF or ZE or these substances are not easy to spread the flame horizontal direction. And if you consider the servicing blazing risk, refrigerant should be removed before the blazing, but sometimes this happens. We know this happens. And the flame of the R32 is something like this, and the lubricant, if you blazing the compressor, generally pressure is, or the refrigerant is solved in lubricant, and sometimes blazing of the compressor, then it flow out with lubricant. Then the risk of the lubricant is much higher than the refrigerant. And this is a real scale picture. So the flame size of the refrigerant is much smaller than the lubricant. And interestingly, R22 and the mineral oil is most flammable because the surface tension of the mineral oil is lower than the synthetic oil. And due to that, the R22 becomes more fine mist and more dangerous. So compared to that, the service risk of the blazing is not so high, but still we need some care for it. And the open flame is generally considered as the ignition source. But if you have a strong ignition source like a gas stove, then the convection is higher than the burning velocity. So the flame is held by flame itself. So it cannot spread horizontal direction. But if you have a weak flame like candle, then it can spread, but still it's slowly moving on the floor. So we see some candles on the entrance of this hotel, so we may be necessary to care about it. And the minimum ignition energy, already some people talking, and the nature of burning velocity and minimum ignition energy is something like this. So if you have a lower burning velocity, then you have a fairly high minimum ignition energy. And if you have a very fine electrode, like here, then you can have the very close to theoretical one. And if you have an actual relay or something, then that is much higher. So some speaker already mentioned very high minimum ignition energy can be measured with these actual relays. And this is the actual measured boundary. So already Mr. Mikoshi mentioned that around 10 kVA, around 10 kilowatt, or if you three-phase, then around 20 kilowatt is the boundary to unite these 12 substance or the 32. But 12 boundary is a little bit fairly lower. And if you go to hydrocarbon, then the far below these values. So any electric component you have to be worried about. But if you consider 32 or 1, 2, 3, 4 YF or these substances, then you worry about very big machines in the factory. Generally, residential or the commercial unit doesn't have such large power. Also, the service tools has to be light, so don't have such large motor. So generally, service tools are safe for regarding the ignition. And this is the pulling effect of the refrigerant. So if you consider the fairly tight room and the very, let's say, high leak rate but slow velocity, then the pulling occurs. And current formula already indicated that this formula is generated considering this worst condition. So if the charge is within this formula, then the accidental release is unlikely to make the flammable cloud. It is dilute itself by velocity. So flammable cloud is unlikely to generate it. Also, if you consider the rapid release with the velocity, then if you only consider the concentration, then the rapid release generates the small flammable cloud with 32 and the large cloud. It's a 10 meter, so 4 meter or something flammable cloud if you release very rapid speed with the propane. But the R32 makes the small flammable cloud. But if you consider the velocity, then the velocity is too high to ignite. So the propane has surely have the real flammable cloud, but R32 doesn't have the real flammable cloud from the practical viewpoint. Also, in addition, that these 12 refrigerant has a fairly high LFL in mass or weight. Then the refrigerant itself is heavier than air and dilute itself fairly quickly. So the flammable cloud generated by the self is dilute itself, and the flammable cloud with 32 or the 1, 2, 3, 4 YF is very small, even if there is no airflow. But in case of hydrocarbon, and the leak rate is much smaller, but still you have a significant flammable cloud and certain risk. And the decomposition may be a problem, but if you consider the actual before the such decomposition occurs, then there is a permanent ignition source, then the decomposition occurs anyway, and the decomposition rate doesn't different from the non-flammable for 10A to 32, and if you compare to 22 is most easy to decompose. And if you consider the overall risks, then we have been living with the R22 toxicity limit, and we don't care about the toxicity of R22. Then the A2L flammability limit is around 300 grams, so more difficult to occur compared to the R22 toxicity limit. And if you consider the hydrocarbon flammability limit, then it's considerably lower than the toxicity limit to 22. So from the experience of R22, the flammability risk of the 12 is quite unlikely to happen. But still, we have to take care of the extreme conditions, like we experienced the toxicity accidents with 22, such as underground machinery room or the piping pits. These very tight and low position, the ignition may happen. But this flammability issue is not so really a big issue for converting from 22 to 32, but actually a lot of issues with HFC is taken care of. Already Mr. Mikoshi or other people mentioned that the HFC is quite different from HCFC, and the molecular size is different and the polarity is different. So moisture effect or the polarity of the substance effect. So you need some care. And this part is not a risk assessment, so I don't talk about, but this should be taken care of. But it takes hours to understand these. Anyway, its refrigerants are commercialized in some region and probably developed to all over the world fairly soon, I believe. And compared to the other process, the service is relatively high risk. And the 12 flammability risk is not so high, but still we have to take care of. And not only HFC, not only flammability, but care for HFC is necessary. And we have to provide appropriate training for 12, not for hydrocarbon is necessary. That's my conclusion. Thank you very much.
So, thank you very much, Kataoka-san, for this summary, and thanks again to all of the speakers for respecting the time very diligently and for giving very interesting presentations about the issues of safety and service. I take away three key messages from all the presentations we heard. The first message, I think, which is very important, is that it cannot be done overnight. The transition needs to be carefully planned and step by step if we move towards low GWP refrigerants. The second message I heard was training, because we heard that most of the accidents occur during service and maintenance, so training is key, contractors are key. And there was one figure which really struck me, which was that in the EU, only 6 to a maximum of 12% of the technicians are properly trained for the use of hydrocarbons, CO2 and ammonia. That's not a lot. And that's the EU, where we have the F-gas regulation already in place. So I think the second message is very important as well, training. And the third one, of course, standards. Standards, be it related to be it related to charge sizes, to installation requirements, to the working environment, etc. Standards are key, they need to be adapted, they are required. Building codes, etc. The whole environment for the use of such refrigerants needs to be ready and needs to be done carefully. So again, it cannot be done overnight. We need to give ourselves time and then it'll work. So thank you very much for everybody for the interesting insights. And we now have 15 minutes, I'm told, more or less, for discussions. So could all the speakers please come to the scene and take a seat, and then we can take questions and answers. Thank you.
Mr. Samir, yes, of Petra.
Samir from Petra. I have a question to Mr. Rajan from Emerson. You mentioned in your presentation that there is a special components made by Emerson for R290 refrigerants. Are you talking about the compressors or the refrigeration accessories or both? And you mentioned also that we cannot replace the normal compressor, the normal score compressor, in using it in R290 applications. I'm not sure if this is, I got this point or not, because we have did many tests using the normal standard compressors in this. I'm not sure it's working, but maybe it's working with some safety issues. I need you please to clarify this. Okay.
Could you wait until we finish because of 5 questions. Dr. Lee, you've got the questions. We'll answer all at the end.
Yes, I'm Tinxun Li from China. So I have 2 questions for Mr. Katoka Asami. So I noticed in your presentation, you have done the CFD simulation. If the propping leak rate is 60 gram per minute, the total flow will get flammable. This is your calculation. But according to our test, the answer is not. So what do you think the difference? The second question is, a lot of tests have been done by you, is mainly on the refrigerant itself. But you have finished the risk assessment about the air conditioner. So what do you think the risk of refrigerant itself and the risk of air conditioner with refrigerant? Do you have test or evaluate air conditioner with propane or with R32? Thank you.
Thank you. Third question over there, please.
Hello. My name is Jay Kumar. I'm from Emerson. I asked this question specifically from a perspective of Middle East organizations and the manufacturers and industry in the region. You know, the question is to Rajan. The reason because he is representing, participates in a lot of the global forums in alternate refrigerants, and to the rest of the panel members. There's a lot of discussion on R290 and alternate refrigerants in Middle East. Then there's a talk of leapfrogging from R22 to alternate refrigerants, low GWP refrigerants. Given what we just heard in this presentation today, that you just can't switch on to an alternate refrigerant, what do you think would be a realistic timeline that we as regional manufacturers in the Middle East, high ambient countries, need before we can switch to such a refrigerant?
Thank you. Fourth question. Yes.
Hi, good afternoon. My name is Kapadia. I am from RIM. My question is to Mr. Kasowasa. Sir, we have been hearing you and your company yesterday and today. There are 2 options available in HFCs, R32 and R290. And both of them are lower GWP, but R290 is lower than R32. You are still concentrating all your energy on R32. May I know why? What is the reason that you are preferring R32 over R290?
Thank you. Dr. Walid? Dr. Walid Shakroun?
Okay, my question to Mr. Olay. We all believe in technology development. I think we have to trust the science that's ahead of us. Do you see any development in using the flammable refrigerants in the next 10 years if we give that as an option for the industry to solve? Because, you know, I think reducing the charge is one of the big issues that we have to deal with in the future. But I think developments could be seen. I mean, it's not really hard to develop something like that, but do you see something like that coming up in the next 10 years?
Dennis, please.
Yes, Dennis Dorman, representing ASHRAE and Train. This is for Bernard. And in one of your slides, you mentioned R290 in chillers, and the picture was an indoor unit, presumably a large one in a mechanical equipment room. Contrast that with most of the other discussions we've heard, small units, RAC, and yesterday we heard about air-cooled chillers located outdoors. So I'm curious, is somebody actually putting an unlimited charge system using R290 indoors?
Thank you. Did you want to ask a question? Yaoub, the last one, yes.
Thank you very much. I'm sorry, I'm always taking the floor, but it's my destiny. So my question is to Bernard and Oli, both of you. Let's be realistic. You want me to train and put a standard for something, I don't have it. I train my people on what? On manuals, I don't have the equipment. It's not on the ground, it's not there. So I train whom? When then I have to start my training and when they have to develop. Andrea said, training and standard. Standard, if I create the standard now, and it's an issue, for equipment it's not existed, and then the equipment will be exist, then my standard will not meet that equipment. Then I have to regenerate the standard for the region. Again, the symposium mentioned alternative refrigerant for high ambient country, which I didn't find it yet. So I need, what is the strategy for us regarding the training, regarding the standard?
Thank you. The first question was from Mr. Samir Hamid of Petra. It was addressed to Mr. Bioni. Your first question? For Dr. Rajan, first question.
Thank you. Yeah, I think I had to write this down. So the question was, when I said that compressors and components are specifically designed for R290, and your question was, is there anything special about it? And you're testing a compressor right now that is not designed for 290 with 290. And my answer back to you will be, you can test any compressor in any application. If you're doing it in a lab, most people do that often. Sometimes with our knowledge, often without us knowing about it. But when we start talking about releasing products and components into production, we have to make sure that the production processes are good, that the quality is good, that the reliability is there, long-term reliability. So, yes, we do subject our R290 compressors that we produce, we subject them to additional processes, additional checks, because as you heard today, leaks are the number one problem. If the propane does not leak, it never leaks out of the refrigeration system, you won't have an issue. But we know that some of these things can happen, so that's why we try to minimize that. So yes, you could probably test a compressor, but would you go into production with a compressor that is not designed for a particular refrigerant? No, I don't think that's a good idea. I hope I answered your question on that. If I did not, I can certainly talk to you after this symposium.
The second question was from Dr. Lee to Mr. Usami Katouk.
Okay. The question was his experiment doesn't ignite, but the CFD is actually generating the flammable cloud. And in experiment, there are so many parameters, and how do you test the substance is the very, so many variety of the result you can get. And if you don't have the turbulence or certain velocity of the release, then we rarely experience the ignition even with the experimental result. So I don't think our CFD is not correct, but your test probably includes some velocity effect to dilute the substance. So that is sure that there is a certain velocity, then the concentration is lower and the ignition may not happen, but in the worst condition, then you surely have the ignition, and that was confirmed with experimentally. That is the first answer. And the second one is product risk is evaluated, and we evaluate it under the certain type of the product contains quite a lot of the plastic, and it's rarely generate a lot of heat when it is combusted. However, this solid never explode, and the ignition only occurs with the ignition of the unit itself. So compared to that, the flammable refrigerant, especially for 290, risk is quite different. That is my understanding.
Yes, please go ahead.
Sorry, I don't disagree with you. Since the sensor we used has carefully calibrated before we do the test. Second, as we know, normally CFD results is, sometimes totally depends on what conditions and what assumption you used. Normally, test data are more reliable than CFD results. Especially, do you have compared or verified your CFD results? If no, so we should believe more on test results, but not CFD simulation results. Thank you.
We calibrate the CFD with the actual release test, and we see fairly a good coincidence of the CFD and testing result. So I think your test has certain another parameter to dilute the substance. That is my conclusion.
Thank you. Mr. Jay Kumar of Emerson to Dr. Rajan.
I think the question to remind myself is whether we can do a conversion to R290 by leapfrogging the rest of the world and going straight to 290 in air conditioning applications. I think I would, and he asked for a realistic timeline, I think I would revert back to the comment that the summary that Andrea Voigt gave us, which is, I thought, a very good summary of all of the materials. She could have just presented everything in 5 minutes. That summary told you that in Europe, how long have they been using hydrocarbons in Europe? Is it 1 year, 2 years, 3, 5, 10? I think it's much longer. And today, they can claim 10% of the technicians are trained for hydrocarbons. I don't think that that is, as she pointed out, I don't think it's a good number. And before my experience in Western nations, I come from India, so I know how things are done in India. And I can tell you that after this many years in a country like India, we would probably not even be at 10%. It is impossible to get to high numbers. So my answer to you would be, I think it is going to be a challenge for all of us. It cannot be done in 1 year, it cannot be done in 2 years. It's hard for me to predict, but I can tell you, whatever it is that Europe is going through, you can probably multiply it by a factor of 2x, 3x, or even 5x, and then put another safety factor on top of that, and look at your timing. His comment was very good. Where are the standards? Where are the training manuals? But then at the end of that, where are the training schools? Who's going to train them? Do you have everything all completely done? I think it is a challenge, and you have to do the entire thing has to be looked at very, very carefully, and you have to you have to take your time about it. So I cannot give you a year, 5, 10, 15 years, but it's definitely not single digit, 1 or 2 or 3 years.
Thank you. The question of Mr. Harish Kapadia to Mr. Katoki-san.
My understanding of this question is why you are going to 32 instead of 290. And the answer is we have been really evaluated to 290 almost 15, 20 years ago when the R22 is required to phase out. And at that time, the risk is too high because the quality of the service person is not so good. And still the conclusion doesn't change. And if you consider the current situation of Japan, Japan is refrigerant recovery is mandatory, but we only recovering only 30%. Mr. Sato indicated yesterday. That means 70% of the refrigerant is released at the end of the life. So at this condition, you can use hydrocarbon or not. That is my question, and my answer is no, that is not acceptable in Japan. And for the moment, we have to stick to 32. And if there is a revolutionary method to service, then we can use hydrocarbon. But at that time, we may not need to such substance because there is no leak. Then we don't need to any substance flammable.
Thank you very much. Professor Dr. Alicia Kroon question to Oli Nelson.
Thank you very much for the question. Being a born optimist, my quick answer is yes. But to elaborate a little more, yesterday we heard from Stephen Jurek that 100 million alternatives have been investigated, and that boiled down to 60. I believe we have exhausted the periodic system, and we will not see any new silver bullet that will solve everything for us. With other words, we know how the refrigerant landscape looks. And then it's a matter of getting wiser, as mentioned by my countryman from Danfoss. We will get wiser, we will learn how to use it, and yes, I believe we will have proper solutions within the next 10 years. If you will allow me just to address Jakub, because he also had a question to me, and I will do that very short, and please don't be offended, but my recommendation will be move from the passenger seat to the driver's seat, try to pursue solutions instead of waiting for them to come to you.
Thank you very much. Thank you, Mr. Oli. With those questions and the answers, one last question. Do we have time? Yes? Okay, short one. Please.
Yes, the one for the chiller, I believe, right?
I think it was a question about the timeline for switch